Welcome to your Algebra 2 lesson 1.7. Today you're going to solve absolute value equations and inequalities, which of course is your objective. Remember, the absolute value of a number x, written bar x bar, is the distance the number is from 0 on the number line. The equation absolute value of x equals k can be written as absolute value of x minus 0 equals k. It means the distance between x and 0 is k. The equation absolute value of x minus b equals k means the distance between x and b is k. Use these steps to solve an absolute value equation, absolute value of ax plus b equals c, where c is greater than 0. Write two equations, ax plus b equals c, or the opposite of ax plus b equals c. So negative of the quantity ax plus b equals c, because we have to go in both directions. That's why we have the two parts. And then you're going to solve each equation. Check each solution in the original absolute value equation. Okay, so our first problem that we have is we're going to solve the absolute value of 5x minus 10 equals 45. So we're going to write our two possible equations here. So we're going to have 5x minus 10 equals 45, or the opposite of 5x minus 10 equals 45. So negative quantity 5x minus 10 equals 45. Now we're going to solve. So 5x minus 10 equals 45. We add 10 to both sides to get 5x equals 55. In our second equation, we distribute the negative to get negative 5x plus 10 equals 45. On the left-hand equation, we divide by 5 to get x equals 11. On the right-hand side, we're ready to subtract 10 from both sides, so we get negative 5x equals 35. We're going to divide that one by negative 5 to get x equals negative 7. Now you always want to check, because it could be the case that both values work and you get true statements. It could be that neither value works and you have no solution. It could be that one works and the other one doesn't, and so you just have one solution. So you've got to check them. So when we check, we just plug in our values for x and simplify. So for the left-hand solution of x equals 11, you substitute 11 in, so you get absolute value of 55 minus 10 equals 45. 55 minus 10 is 45. Absolute value of 45 is 45, so 11 is a solution. For negative 7, you plug in negative 7. Times 5 is negative 35. Minus 10 is negative 45. The absolute value of negative 45 is 45, so negative 7 works. So we actually have two solutions, 11 and negative 7, which we can put in a cute little solution set. When you solve an absolute value equation, it is possible for a potential solution to be extraneous. I was talking about that earlier. This means that the potential solution does not give you a true statement when plugged back into the original equation. So you have to check your potential solutions. Okay, so we're going to solve the absolute value of 2x plus 12 equals 4x, and we're going to check for extraneous solutions. So we write down our two cases. The first case, 2x plus 12 equals 4x, and then we write or. The opposite equals 4x, so negative quantity 2x plus 12 equals 4x. Alright, so we start solving. So on the left-hand equation, we subtract 2x over and get 12 equals 2x. On the right-hand equation, we distribute the negative, so we get negative 2x minus 12 equals 4x. On the left-hand equation, we're ready to divide by 2, we get 6 equals x. On the right-hand side, we add 2x to both sides, and we get negative 12 equals 6x. Divide by 6, and we get negative 2 equals x. Now, if it's confusing for you to work one step on one equation, one step on the other, what you can do is just work through the first case and then come back and work through the second case. That's fine. But we do need to check both solutions. So let's plug in 6. So we get absolute value of 2 times 6 plus 12 equals 4 times 6. We've got x on both sides of the original equation, so we're plugging in 6 everywhere we have x. Absolute value of 12 plus 12 is absolute value of 24. 24 equals 24. We're good to go. Over here, we plug in negative 2 everywhere we see x. So we have absolute value of 2 times negative 2 plus 12 equals 4 times negative 2. 4 times negative 2 is negative 8. Inside our absolute value signs, we have absolute value of negative 4 plus 12. So absolute value of 8 equals negative 8, which means we're saying 8 equals negative 8, which is false. So the only solution that works is 6. We've got to reject the negative 2. Now, just so you know, you have to go through this process. You will lose credit if you don't show that you tried to find the second solution and it didn't work out in this case. So make sure you show all steps. So we get 6 for our final answer. But on a problem like this, I would be checking all this work to make sure you have it. Okay, so now let's move to inequalities. You're going to use these steps to solve an absolute value inequality. You're going to write two statements. Again, the two cases. What you need to remember is with absolute value, if you've got greater, it's or. If you've got less than, it's and. So greater or, less than, and. So if you start off with absolute value of ax plus b greater than c or greater than or equal to c, you're going to write your two cases with an or. Okay, ax plus b greater than c or greater than or equal to c, or the opposite, greater than c or greater than or equal to c. So greater or. For less than, it's the same kind of thing, but you're going to use and. Less than and. So ax plus b is less than c or less than or equal to, and then the opposite is less than c or less than or equal to c, depending on what you start with. You're going to solve each inequality and graph each inequality on the same number line to determine the final solution set. Okay, so let's look at absolute value of 4x plus 5 greater than 13. So this is absolute value, so it's either an or and, because you're going to have two cases, and since it's greater, it's going to be or. Okay, so we have 4x plus 5 greater than 13, or negative 4x plus 5 greater than 13. Again, we start solving. For the left-hand equation, let's say we subtract 5 and we get 4x greater than 8. Divide by 4 to get x greater than 2. On the right-hand equation, we distribute the negative. So we get negative 4x minus 5 greater than 13. And let's say we have negative 4x greater than 18. So we're going to divide both sides by negative 4. What do we do when we divide by negative? Because we're just about to do that. We're going to divide both sides by negative 4. That's right, we reverse the inequality. So x is less than 18 divided by negative 4, which reduces to negative 9/2. Okay, so in order to be a solution, x has to be greater than 2 or less than negative 9/2. Let's put that on our number line. So here we've got x less than negative 9/2, and here we have x greater than 2. I should have a little blue arrow on that part right there. So color in the arrow there too. So x less than negative 9/2, x greater than 2. And our final solution, x greater than 2 or x less than negative 9/2. Alright, a professional baseball should weigh 5.12 ounces with a tolerance of 0.125 ounce. Write and solve an absolute value inequality that describes the acceptable weights for a baseball. Okay, your verbal model is going to be the absolute value of actual weight minus ideal weight is less than or equal to the tolerance. That way the actual weight is within the tolerance allowed. So algebraically, W, the actual weight, minus 5.125 is less than or equal to 0.125. So let's split up into our two cases. Now this is less than, so we're going to connect with and. If it's greater, we connect with or, only when we have absolute values. So we have W minus 5.125 is less than or equal to 0.125, and the opposite of the quantity, W minus 5.125 is less than or equal to 0.125. So for the first case, we're ready to add the 5.125 to both sides, so we get W less than or equal to 5.125, and let's see, over here on the second case, we're ready to distribute, so we've got negative W plus 5.125 is less than or equal to 0.125. So now we can subtract 5.125 and get that negative W is less than or equal to negative 5. divide both sides by -1, and what do we have to remember to do? That's right, reverse the inequality sign. So we get W greater than or equal to 5. So the weight has to be bigger than or equal to 5, and less than or equal to 5.25. So let's look at that. So 5 or bigger, 5.25 or smaller, and means both has to be true, so it's just where they overlap. So there you go. It starts at 5 with a closed endpoint, ends at 5.25 with a closed endpoint, and any weight in between. So 5 is less than or equal to W is less than or equal to 5.25. Last problem. The thickness of the mats used in the rings, parallel bars, and vault events must be between 7.5 and 8.25 inches inclusive. That means the 7.5 and the 8.25 are part of the acceptable range of values. Write an absolute value inequality describing the acceptable mat thickness. We'll calculate the mean of the extreme mat thicknesses. So 7.5 plus 8.25 divided by 2 is 7.875. Find the tolerance by subtracting the mean from the upper extreme. So 8.25 minus 7.875 is 0.375. All right, so we calculated the mean and we found the tolerance. The verbal model is absolute value, don't want to forget that, of actual thickness minus mean of extremes is less than or equal to tolerance. So the absolute value of T, the actual thickness, minus 7.875 is less than or equal to 0.375. So a mat is acceptable if its thickness T satisfies the absolute value of T minus 7.875 is less than or equal to 0.375. Now it's your turn. So do the problems to try on your own. If you can't do them, if you can't attempt them and do a good job with them, please either rewatch the appropriate sections of the video or come in and get some help so that you can, because you've got to have them done to get full credit for your notes. Okay guys, I'll see you in class. Have a good day.